Welcome to the Junos OS Basic Design Architecture module. By the end of this module, you should be able to describe the Junos OS and its basic design architecture. Junos OS functionality is compartmentalized into multiple software processes. Each process handles a portion of the device's functionality. Each process runs in its own protected memory space, ensuring that one process cannot directly interfere with another. When a single process fails, the entire system does not necessarily fail. This modularity also ensures that new features can be added with less likelihood of breaking the current functionality. Junos OS is the trusted, secure network operating system powering the high-performance network infrastructure offered by Juniper networks. Depending on the platform, Junos OS runs on a modified and hardened version of either FreeBSD or Linux. Junos OS runs on both physical and virtual network devices. Physical devices include hardware routers, such as Juniper MX series, switches such as Juniper EX series and QFX series, and security devices such as Juniper SRX series. Virtual devices include Virtual MX or VMX and Virtual SRX or VSRX running as virtual machines. Another aspect of Junos modularity is the separation of the control plane and the forwarding or data plane. The processes that control routing and switching protocols are cleanly separated from the processes that forward frames, packets, or both through the device running the Junos OS. This design permits you to tune each process for maximum performance and reliability. The separation of the control and forwarding planes is one of the key reasons why the Junos OS can support many different platforms from a common code base. The diagram illustrates a basic view of the Junos OS architecture and highlights the control and forwarding planes. The control plane runs on the routing engine. The routing engine is the brain of the platform. It is responsible for performing protocol updates and system management. The routing engine runs various protocol and management software processes that reside inside a protected memory environment. The routing engine is based on an x86 or PowerPC architecture, depending on the specific platform running the Junos OS. The routing engine maintains the routing tables, also known as Routing Information Base or RIB, bridging table, and primary forwarding table, also known as Forwarding Information Base or FIB, and connects to the Packet Forwarding Engine or PFE through an internal link. Although all Junos devices share this common design goal, the actual components that make up the control and forwarding planes vary between different Junos devices. For additional details about a specific Junos device, refer to the Juniper Networks Tech Library website. You can access the website from the reference links document. The PFE usually runs on separate hardware and is responsible for forwarding transit traffic through the device. In many platforms running the Junos OS, the PFE uses ASICs for increased performance. Because this architecture separates control operations, such as protocol updates and system management, from forwarding operations, platforms running the Junos OS can deliver superior performance and highly reliable deterministic operation. The PFE receives the forwarding table from the routing engine by means of an internal link. Forwarding table updates are a high priority for the Junos OS kernel and are performed incrementally. Because the routing engine provides the intelligence side of the equation, the PFE can simply perform as it is instructed. That is, it forwards frames, packets, or both with a high degree of stability and deterministic performance. This architectural design also makes possible the incorporation of high availability features, like graceful routing engine switchover or GRES, non-stop active routing or NSR, and unified in-service software upgrades or ISSUs. The routing engine handles all protocol processes in addition to other software processes that control the device's interfaces, the chassis components, system management, and user access to the device. These software processes run on top of the Junos kernel, which interacts with the PFE. The software directs all protocol traffic from the network to the routing engine for the required processing. The routing engine provides the user interfaces, namely CLI, JWeb GUI, and Junos APIs, such as Network Configuration Protocol or NetConf, Representational State Transfer or REST, and Juniper Extension Toolkit or JET. These user interfaces run on top of the Junos kernel and provide user access and control of the device. Also, the routing engine performs configuration management. Junos OS Chassis Process, or Chassis D, enables you to configure and control the properties of the router, including conditions that trigger alarms. The Chassis D on the routing engine communicates directly with its peer processes running on the PFE. The routing engine controls the PFE by providing accurate, up-to-date Layer 2 and Layer 3 forwarding tables, and by downloading microcode and managing software processes that reside in the PFE's microcode. The routing engine receives hardware and environmental status messages from the PFE and acts upon them as appropriate. The PFE is the central processing component of the forwarding plane. The PFE systematically forwards traffic based on its local copy of the forwarding table. The PFE's forwarding table is a synchronized copy of the information created on and provided by the routing engine. Storing and using a local copy of the forwarding table enables the PFE to forward traffic more efficiently and eliminates the need to consult the routing engine each time a packet needs to be processed. Using this local copy of the forwarding table also permits platforms running Junos OS to continue forwarding traffic during control plane instabilities. The PFE also maintains Layer 2 bridging information. In addition to forwarding traffic, the PFE also implements a number of advanced services. Some examples of advanced services implemented through the PFE include policers that provide rate limiting, stateless firewall filters, and class of service or COS. Other services are available through special interface cards that you can add to the PFE complex. Welcome to the Traffic Processing module. By the end of this module, you should be able to explain traffic processing for transit and exception traffic. Transit traffic consists of all traffic that enters an ingress network port, is compared against the forwarding table entries, and is finally forwarded out an egress network port toward its destination. A forwarding table, also known as Forwarding Information Base or FIB entry for a destination, must exist for a device running Junos OS to successfully forward transit traffic to the destination. Transit traffic passes only through the forwarding plane and is never sent to or processed by the control plane. By processing transit traffic only through the forwarding plane, platforms running Junos OS can achieve predictably high performance transfer rates. Transit traffic can be both unicast and multicast traffic. Unicast transit traffic enters one ingress port and is transmitted out exactly one egress port toward its destination. Although multicast transit traffic also enters the transit device through a single ingress port, it can be replicated and sent out through multiple egress ports depending on the number of multicast receivers and the network environment. Unlike transit traffic, exception traffic does not pass through the local device, but rather requires some form of special handling. Examples of exception traffic include packets addressed to the chassis, such as routing protocol updates, telnet sessions, pings, traceroutes, and replies to traffic sourced from the routing engine, IP packets with the IP options field. The options in the packet's IP header are rarely seen, but the packet forwarding engine was purposely designed not to handle IP options. Packets with IP options must be sent to the routing engine for processing. And traffic that requires the generation of Internet Control Message Protocol or ICMP messages. ICMP messages are sent to the packet source to report various error conditions and to respond to ping requests. Examples of ICMP errors include destination unreachable messages, which are sent when no entry is present in the forwarding table for the packet's destination address, and time to live, or TTL expired messages, which are sent when a packet's TTL is decremented to 0. In most cases, The PFE process handles the generation of ICMP messages. Junos OS sends all exception traffic destined for the routing engine over the internal link that connects the control and forwarding planes. The Junos OS rate limits exception traffic traversing the internal link to protect the routing engine from denial of service or DOS attacks. During times of congestion, Junos OS gives preference to the local and control traffic destined for the routing engine. The built-in rate limiter is not configurable. Welcome to the CLI Modes and Features module. By the end of this module, you should be able to describe the Junos CLI and its features. The Junos CLI is a text-based command shell. One option for accessing the CLI is through the out-of-band serial console connection. The console port settings are predefined and are not user-configurable. On virtualized Junos OS devices, such as the VSRX and VMX, the out-of-band console is provided by the Hypervisor Virtual Console. The second option for accessing the CLI is over the network using access protocols, such as Telnet or SSH. Unlike the console connection, these access options require the configuration of a network port and the access protocol. Many platforms running the Junos OS also offer a dedicated management Ethernet port. This management port provides out-of-band access. Therefore, the software cannot forward transit traffic through this management port. The actual name of the dedicated management Ethernet port varies between platforms. For details on a specific platform, refer to the Juniper Network's Tech Library website. You can access the website from the reference links document. Junos OS requires a username and a password for access. The administrator creates user accounts and assigns permissions. All platforms running the Junos OS have only the root user configured by default, without any password. When configured, the console login displays the hostname of the device. When you have not configured a hostname, as is the case with a factory default configuration, the software displays Amnesiac in place of the hostname. The root user has complete access and control of the device. When you log in as the root user, the software places you at the Unix shell. You must start the CLI by typing the CLI command. When you exit the CLI, you return to the Unix shell. For security reasons, ensure that you also log out of the shell by using the exit command. Non-root users are placed in the Junos CLI automatically. They can access the shell if required, and if permissions allow, by using the Start Shell command. In the operational mode, you use the Junos CLI to monitor and troubleshoot a device. Commands like monitor, ping, show, test, and traceroute enable you to display information and test network connectivity for a device. In configuration mode, you can configure all properties of Junos OS, including interfaces, protocols, and user access, as well as several system hardware properties. The CLI provides context-sensitive help at any point in a command line in both operational and configuration modes. Help notifies you which options are acceptable at the current point in the command and provides a brief description of each command or the command option. To receive help at any time while in the Junos CLI, type a question mark. You do not need to press Enter. If you type the question mark at the command line prompt, the CLI lists the available commands and options, including user-defined variables at the appropriate context. If you type the question mark after entering the complete name of a command or an option, the CLI lists the available commands and options and then redisplays the command name and options that you typed. If you type the question mark in the middle of a command name, the CLI lists possible command completions that match the letters you have entered so far, and then redisplays the letters that you typed. The CLI provides a completion function. Therefore, you are not always required to type the full command or the command option name for the CLI to recognize it. To complete a command or an option that you have partially typed, press the spacebar. If the partially typed letters begin a string that uniquely identifies a command, The CLI displays the complete command name. Otherwise, the CLI beeps to indicate that you have entered an ambiguous command, and it displays the possible completions. The command completion option is on by default, but you can turn it off. To disable command completion for an individual user's session, issue the Set CLI Complete On Space Off command. You can use the Tab key to complete system commands and user-defined variables. Examples of variables include policy names, autonomous system or AS paths, community names, and IP addresses. The Tab key also offers a list of possible completions if multiple, ambiguous options exist. Command completion enables you to save time by reducing your keystrokes and prevents errors by accurately referencing the desired user-defined variables. The CLI supports Emacs-style keyboard sequences that permit you to move the cursor on a command line and delete specific characters or words. This table lists the supported sequences. Please note that when using the Escape key, you must release the key and press it again for each occurrence. This action differs from the Control key, which you can hold down for multiple occurrences. Junos OS defaults to a VT100 terminal type. This terminal type enables the use of keyboard arrow keys without any additional session or configuration modification. For operational and configuration commands that display output, such as the show commands, you can filter the output. When help is displayed for these commands, one of the options listed is called a pipe that enables the command output to be filtered. To filter the output of an operational mode or a configuration mode command, add a pipe and an option to the end of the command. The append option is used to append output text to an existing file. The compare option is available in configuration mode using the show command. It compares configuration against another configuration file. The count option displays the number of lines in the output. The display changed option is available in configuration mode only. It displays configuration that is tagged with the Junos changed attribute. The display commit scripts option displays configuration data after Junos OS applies any commit scripts. The display detail option is available in configuration mode and displays additional information about the contents of the configuration. The display inheritance option is available in configuration mode and displays inherited configuration data and the source configuration group. The display omit option omits configuration statements containing the omit option. The display set option displays the Junos OS set commands that created the configuration statements. The display XML option displays output in XML format. And the display JSON option displays the output in JavaScript Object Notation or JSON format. There are other options available to filter the output. The Accept Regular Expression option ignores text matching a regular expression when searching the output. If the regular expression contains spaces, operators, or wildcard characters, you must enclose it in quotation marks. The Find Regular Expression option displays the output starting at the first occurrence of text matching a regular expression. If the regular expression contains spaces, operators, or wildcard characters, you must enclose it in quotation marks. The Hold option holds text without exiting the More prompt. The Last option displays the last screen of information. The Match Regular Expression option searches for text matching a regular expression. If the regular expression contains spaces, operators, or wildcard characters, you must enclose it in quotation marks. And the No More option displays output all at once rather than one screen at a time. The Refresh option enables you to refresh a continuous display of the command at a specified time interval. The Request Message option displays output to multiple users. The Resolve option converts IP addresses to Domain Name System, or DNS names. The option truncates to fit original size unless you specify full names. The Save File Name option saves the output to a file or URL. The T option writes command output both to standard output and file. And the Trim option trims a specified number of columns from the start line. You can cascade multiple instances of the CLI's pipe functionality, which can be very beneficial when you must search extensive output displayed by the CLI for specific information. You use operational mode CLI commands to monitor and control the operation of a device running Junos OS. The operational mode commands exist in a hierarchical structure. For example, the show command displays various types of information about the system and its environment. One of the possible options for the show command is OSPF, that displays information about the OSPF protocol. Specifying the interface option, as in the show OSPF interface command, outputs information about OSPF interfaces. Junos OS also adds additional flexibility through the Run command that enables you to issue operational mode commands while in configuration mode. You enter configuration mode by issuing the Configure command from the Junos CLI's operational mode. If you enter configuration mode and another user is also in configuration mode, a message indicates who the user is and what portion of the configuration the user is viewing or editing. In configuration mode, the prompt changes from the angle bracket of the operational mode to the pound sign, preceded by the name of the user and the host name of the device. The portion of the prompt in brackets, such as Edit, is a banner indicating that you are in configuration mode and identifies your location within the configuration hierarchy. By default, multiple users can enter configuration mode and commit changes. This is called shared configuration. Use the Configure Exclusive command to allow only a single user to edit the configuration. Uncommitted changes are always discarded when you use the Configure Exclusive command. In contrast, uncommitted changes are retained when you use the standard Configure command. Entering configuration mode using the Configure Private command allows multiple users to edit the configuration while committing only their private changes. If private users issue a rollback 0 command, the software discards only their changes. When a user is in private mode, other users must enter private mode or use Configure Exclusive to become the primary user, or they cannot modify the candidate configuration. Exiting the private configuration without committing changes results in the loss of any modifications made to the private candidate configuration. If a user is in a shared configuration mode and has altered the candidate configuration, other users cannot enter configuration mode using the exclusive or private options. The changes made by the first user must be committed or canceled prior to any other users entering configuration mode with the exclusive or private options. Unlike software from other vendors, configuration changes made in Junos OS do not take effect immediately. This design feature permits you to group together and apply multiple configuration changes to the running configuration as a single unit. The active configuration is the configuration currently operational on the system, and is the configuration the system loads during the boot sequence. This concept is analogous to both the running configuration and startup configuration in software from other vendors. The candidate configuration is a temporary configuration that might possibly become the active configuration. When you configure a device running Junos OS, the software creates a candidate configuration and initially populates it with the copy of the active configuration running on that device. You then modify the candidate configuration. Once satisfied with your modifications, you can commit the changes. This action causes the candidate configuration to become the active configuration. The Configure command causes a candidate configuration to be created and populated with the contents of the active configuration. You can then modify the candidate configuration with your changes. To have a candidate configuration take effect, you must commit the changes. At this time, Junos OS checks the candidate configuration for proper syntax, and it installs it as the active configuration. If the syntax is not correct, an error message indicates the location of the error, and the software does not activate any part of the configuration. You must correct the errors before recommitting the configuration. You can easily recover previous configurations by using a rollback command. Junos OS maintains a configuration history by storing previously active configurations. The software saves a maximum of 50 configurations. This number includes the current active configuration, which is also known as rollback 0, and up to 49 previously active configurations. If you perform a rollback operation, keep in mind that the related configuration does not become active until you issue a commit. When you issue a commit and 50 rollback configurations exist, the software purges the last rollback configuration. In configuration mode, you enter commands that affect the configuration hierarchy. The configuration hierarchy stores configuration information and is independent of the CLI operational mode command hierarchy. The commands available in configuration mode are also independent of the commands available in operational mode. For example, operational mode includes a show command that displays specific operational information, while configuration mode provides a show command that displays the configuration hierarchy. The two commands are independent of each other. The software organizes the statement hierarchy in a tree structure similar to Windows folders or Unix directories, grouping related information into a particular branch of the tree. Use configuration mode set commands to modify the candidate configuration. Use the show command to display the candidate configuration. Both commands are relative to the current configuration hierarchy shown by the edit prompt. Configuration files use curly brackets and indentation to visually display the hierarchical structure of the configuration. Terminating, or leaf, statements in the configuration hierarchy are displayed with a trailing semicolon. You enter neither the curly brackets nor the semicolons as part of the set command. To move down through an existing configuration statement hierarchy, or to create a new hierarchy and move down to that level, use the edit command specifying your desired hierarchy level. After you issue an edit command, the configuration mode banner changes to indicate your current level in the hierarchy. To move up one level from the current position in the hierarchy, use the up command. To move up more than one level from the current position in the hierarchy, supply an optional count to the up command. The software moves you up the specified number of levels or to the top of the hierarchy if there are fewer levels than specified. The top command quickly moves you to the top of the configuration hierarchy. You can combine top with edit to move quickly to a different hierarchy, or with show to display the configuration details for a different hierarchy, as in this example. This example illustrates how the exit command returns the user to the most recent, higher level of the hierarchy. Entering exit at the top level of the hierarchy exits configuration mode. Entering the exit configuration mode from any level of the hierarchy also enables you to exit the configuration mode, as in this example. You can quickly navigate between levels of the configuration hierarchy using the edit, up, top, and exit commands. Welcome to the CLI Configuration module. By the end of this module, you should be able to describe the Junos CLI configuration. The Junos CLI is a text-based command shell. In configuration mode, you can configure all properties of the Junos OS, including interfaces, protocols, and user access, as well as several system hardware properties. You use set commands in configuration mode to modify the device's candidate configuration. Use the configuration mode delete command to remove statements that you previously added to the configuration with a set command. This command deletes the statement and all its subordinate statements and identifiers. Deleting a statement or an identifier effectively unconfigures the functionality associated with that statement or identifier, returning that functionality to its default condition. Consider using the wildcard delete function when deleting individual statements is too arduous and deleting an entire configuration sub-hierarchy lacks the granularity that you need. This example is the sample syntax for a wildcard delete. In addition to deleting configuration statements, you should also consider the use of the deactivate command to cause the specified portion of the configuration hierarchy to be ignored while still retaining the original configuration. Issue an activate command to place the configuration back into effect. Using the configuration commands, such as rename, replace, insert, and copy, can increase efficiency. Regardless of the method and commands you use to update your configuration file, you must issue the commit command to activate changes. This example shows the deactivate, activate, annotate, and commit commands and their output. Use the configuration mode show command to display the candidate configuration. This command displays the configuration at the current hierarchy level or at the specified level below the current location. The show command has the show statement path. When displaying the configuration, the CLI indents each subordinate hierarchy level, inserts curly brackets to indicate the beginning and end of each hierarchy level, and places a semicolon at the end of each statement that is at the lowest level of the hierarchy. The display format is the same format you use when creating an ASCII configuration file, and it is also the same format that the CLI uses when saving a configuration to an ASCII file. In cases where an empty statement leads to an invalid configuration, because it is incomplete or meaningless, the show command does not display any of the statement path. You can display the individual set commands used to create the existing configuration file using the show pipe display set command. An example of this command and its resulting output is shown. Using show pipe compare displays the differences between the candidate configuration and the active configuration, also known as rollback 0. Configuration comparison is patch-like and context-sensitive. Thus, instead of showing the entire configuration, the display shows only the actual changes. Using the operational mode, the show configuration pipe compare rollback command enables you to view differences between the active configuration and rollback configurations. Junos OS can store up to 49 additional rollback configurations in addition to rollback 0, which is the active configuration. Similarly, the show configuration pipe compare command enables you to compare the active configuration to an arbitrary file. You can also use the show pipe compare rollback and show pipe compare file name commands in configuration mode to compare the candidate configuration with rollback configurations and arbitrary files. You can use the show system rollback compare operational mode command to compare two arbitrary rollback configurations, referencing them by numbers. The operational mode file compare files command enables you to view differences between any two text files, including log files. The output of this command is in the same patch-like format as the show pipe compare command. Remember, Junos OS devices do not automatically apply your configuration changes. You must use the commit command to activate your candidate configuration. You can typically perform the commit operation from any hierarchy level. The exception is when users enter configuration mode using the configure private option that requires the commit command to be issued at the top of the configuration hierarchy. On devices with redundant routing engines, you can perform a commit synchronize operation, which activates and synchronizes the configuration on both routing engines. Alternatively, you can configure the system to automatically perform the synchronize operation when a standard commit is issued through the set system commit synchronize command. When you commit a candidate configuration, the software activates the entire configuration in its current form. Use the commit check command to validate the syntax of a candidate configuration without actually placing it into effect. The commit check cannot catch logical errors in your configuration. What happens when you are configuring a device remotely and make a mistake that leaves that device inaccessible? You can avoid this scenario by using the commit confirmed command. When you issue a commit confirmed command, the system starts a timer, during which it expects to see another commit operation performed. If a second commit does not occur within the timeout value specified, the system automatically performs a configuration rollback operation. You can also schedule a commit that occurs at a specific time using the commit at command. This command is useful for synchronizing commits with multiple routers. These routers must have their time synchronized to the same source, likely through Network Time Protocol or NTP, for the commit operations to execute at the same time. To view and clear pending commits, use the Show System Commit and Clear System Commit commands. You can also add information about a commit event to your system's commit log using the commit comment command. You can add the and quit option to a commit command to activate your changes and exit configuration mode in a single step. The Junos OS software saves the last 50 committed versions of the configuration. To overwrite the candidate configuration with one of these previously committed versions, use the rollback command. By default, the system returns to the most recently committed configuration, the active configuration. To return to a version prior to the configuration most recently committed, include the version number in the rollback command. The n argument can be a number in the range 0 through 49. The most recently saved configuration is version 0, which is the active configuration. The oldest committed configuration the software automatically saves is version 49. The factory default configuration on some of the smaller Junos OS devices restricts the number of rollback files stored by the system. This default setting can be changed to increase the number of rollback files as shown in the example. The rollback command modifies only the candidate configuration. To activate the changes loaded through the rollback operation, issue the commit command. The configure command causes a candidate configuration to be created and populated with the contents of the active configuration. You can then modify the candidate configuration with your changes. To have a candidate configuration take effect, you must commit the changes. At this time, Junos OS checks the candidate configuration for proper syntax and it installs as the active configuration. If the syntax is not correct, an error message indicates the location of the error, and the software does not activate any part of the configuration. You must correct the errors before recommitting the configuration. You can easily recover previous configurations with a rollback command. Junos OS maintains a configuration history by storing previously active configurations. The software saves a maximum of 50 configurations. This number includes the current active configuration, which is also known as rollback 0, and up to 49 previously active configurations. If you perform a rollback operation, keep in mind that the related configuration does not become active until you issue a commit command. When you issue a commit command and there are 50 rollback configurations, the software purges the last rollback configuration. You can save the candidate configuration from your current configuration session to an ASCII file using the save command. Saving a candidate configuration saves the configuration in its current form, including any uncommitted changes. Note that you are saving only the configuration statements at the current hierarchy level and below. To save the entire candidate configuration, you must be at the top level of the configuration hierarchy. If you do not specify a path, Junos OS saves the configuration to the user's working directory. You can specify a file name and path in many ways. You can use the configuration mode load command to load a complete or partial configuration from a local file, from a file on a remote machine, or from a terminal emulation program's capture buffer. The load command supports several arguments that determine the specifics of the operation. The following list provides details for some of the arguments to the load command. The factory default argument replaces the full current configuration with the factory default configuration. The merge argument combines the current configuration with the configuration you load. The override argument completely overwrites the current configuration with the configuration you load. You must perform override operations at the top of the configuration hierarchy. The patch argument adds or deletes variables from the configuration based on the contents of a specified patch file. The patch file used in this operation uses the contextual diff format. The file generated from a show pipe compare pipe save operation creates such a file. The replace argument looks for a replace tag in the configuration you load. The software replaces existing statements of the same name with those in the loaded configuration stanzas. The set argument enables users to load set commands from the terminal or from a saved file that consists of set configuration statements. The update argument updates the existing configuration with the configuration you load. When the update option is used, Junos OS attempts to notify only those processes affected by the configuration changes. When the override option is used, Junos OS makes no such attempt. You can use the update option from any hierarchy, but you can use the override option only from the top-level hierarchy. The terminal option uses the text you type or paste at the terminal as input to the configuration. Type Ctrl-D to end the terminal input. This option is usually used in conjunction with a terminal emulation program's copy and paste functionality to copy and paste configuration data from one system to another. The relative option is normally used during a load merge or load replace operation. The relative option negates the requirement that the data you load contains a full path to the related configuration hierarchy and tells the device to add the data you load relative to the current configuration hierarchy. In all cases, after the load operation is complete, you must issue a commit to activate the changes made to the configuration. The run command enables you to execute operational mode commands while in configuration mode. It is similar to the do command on equipment from other vendors, but much more flexible. This extremely handy time saver works for all operational mode commands, and the software supports it at all configuration hierarchies. In the example, the configuration for the device's GE0/0/12 interface is defined. After assigning the IP address, the change is committed, and the run command is used to execute a quick ping test. Welcome to the Initial Configuration Tasks module. By the end of this module, you should be able to explain how to list and perform initial configuration tasks. Refer to your platform-specific documentation and follow the safety guidelines when connecting power and powering on your device running Junos OS. If a Junos OS device is powered on and power to that system is interrupted, the device automatically powers on when the power is restored. In other words, no manual intervention is required for the system to reboot. Junos OS is a multitasking environment. To ensure file system integrity, you should always gracefully shut down platforms running Junos OS. Although unlikely, failure to gracefully shut down the system could possibly leave it unable to boot. As shown in this example, you can use the request system halt command to gracefully shut down Junos OS. This command provides options that enable you to schedule the shutdown in a specified number of minutes or at an exact time, to specify the media from which the next boot up operation uses, and to log a message to the console and to the messages file. For Junos devices that offer redundant routing engines, you can halt both routing engines simultaneously using the request system halt both routing engines command. For EX series switches participating in a virtual chassis, where multiple switches function as a single virtual device, you can halt all participating members simultaneously with the Request System Halt All Members command. All platforms running Junos OS are shipped with a factory default configuration. All factory default configurations allow access using the root account. The root account does not include a password by default. Setting a root password is required before activating any changes to the configuration file. All factory default configurations also include system logging, which tracks system events and writes those events to predefined log files, such as the messages file. Factory default configurations can vary from one platform family to another, or even between the different models within the same platform family. All platforms running Junos OS are designed for specific roles within a network environment, and their factory default configurations are created with those specific roles in mind. One example is the EX series switches that are designed to operate as Layer 2 switches right out of the box. To meet this default operational requirement, the associated factory default configurations have all interfaces configured for Layer 2 operation, and also include protocol configuration, such as the Rapid Spanning Tree Protocol, or RSTP, and the Link Layer Discovery Protocol, or LLDP, commonly used on switches. Other platforms do not have these same default operational requirements, and so do not include those configuration parameters in their factory default configurations. Under certain conditions, you might want to return a device running Junos OS to its factory default configuration. You can overwrite the candidate configuration while in configuration mode using the Load Factory Default command. Junos OS does not permit you to save the configuration until you configure root authentication information. Do not forget to issue a commit command to activate your changes. When you receive a device running Junos OS from the factory, Junos OS is pre-installed. Once you power on the device, it is ready to be configured. When the initial configuration is performed, the root authentication must be included. In addition to root authentication, we also recommend that you configure a few additional items, such as host name, system time, system services for remote access like Telnet or SSH, and a management interface and a static route for management traffic. Junos OS enforces password restrictions. All passwords are required to be no less than 6 characters and must include a change of case, digits, or punctuation. Remember, when you receive a platform running Junos OS from the factory, the root password is not set. To log in to the CLI for the first time, you must log in through the console port using the root username with no password. When configured, the console login displays the hostname of the device. When no hostname is configured, or if a factory default configuration is loaded, the word amnesiac is displayed in place of the hostname. When you log in as the root user, you are placed at the Unix shell. You must start the CLI by typing the CLI command. When you exit the CLI, you return to the Unix shell. For security reasons, make sure you also log out of the shell using the exit command. After starting the CLI, you enter operational mode. You can make changes to the configuration only in the configuration mode. Enter configuration mode by entering configure at the operational mode prompt. The example shows how to use the CLI to configure the hostname and a root password. As displayed, a check is made when the root password is entered to ensure that it has been entered correctly. In the event that the entered passwords do not match, an error is generated. The change is not accepted, and the password needs to be re-entered. The example uses the plain text authentication option. Unlike the software from some vendors, Junos OS never actually displays the password in its plain text format, but rather encrypts, actually hashes the password for you. You can see the encrypted password by viewing the relevant configuration part. Because you cannot retrieve the passwords by looking at the configuration file, you should keep the configured passwords in a secure location. If you do forget the password and cannot log in, you can perform the Junos OS root password recovery process. The example shows how to use the CLI to enable SSH access to a device running Junos OS. You can enable the Telnet, FTP, or Web Management Services similarly. When connecting to a device running Junos OS using one of these access protocols, use the same user logins defined under the Edit System Login hierarchy. This example shows how to use the CLI to configure the time settings. You can configure the current date and time information along with the proper time zone for the device. The default time zone on Junos OS devices is UTC or GMT. When you define the local time on a Junos OS device, you must account for the time difference between the defined time zone and the default time zone. Once the time zone is changed and committed, the local time is adjusted accordingly to account for the difference. If you do not want to make the necessary adjustments, you can simply set the system's time after the defined time zone parameter has been committed. Instead of setting the local time on each network device in your network, consider implementing Network Time Protocol, or NTP, using the basic NTP configuration as shown in this example. This example shows how to use the CLI to configure a management interface and a static route for management traffic. Note that it is highly discouraged to use a default static route for management traffic. You should be as specific as possible. You can also use the No Re-Advertise option for the static route used for management traffic. The No Re-Advertise option marks the route ineligible for re-advertisement through routing policy. Note that the static route defined for management traffic or any other traffic is only available when the system's routing protocol process or RPD is running. When Junos OS devices boot, the RPD is not running. Therefore, the system has no static or default routes. To allow the device to boot and to ensure that it is reachable over the network during RPD failure, you configure a backup router, which is a router or gateway device that is directly connected to the local system that is on the same subnet. To configure a backup router running IPv4, include the backup router statement at the Edit System hierarchy level. In this sample configuration, hosts on the 10.0.1.0/24 subnet are reachable through the backup router. If the destination statement is omitted, then all hosts are reachable through the backup router. To eliminate the risk of installing a default route in the forwarding table, you should always include the destination option, specifying an address that is reachable through the backup router. Specify the address in the format network or mask length as shown in the example, so that the entire network is reachable through the backup router. When the routing protocols start, the address of the backup router is removed from the local routing and forwarding tables. To have the address remain in these tables, configure a static route for the desired destination prefix with the backup router as the next hop and the retain option as shown. Once you complete your initial configuration, use the commit command to apply your changes. You can include the and quit option, as shown, to return to operational mode. In the example, you see that once the configuration changes are activated and the user returns to operational mode, the configured hostname is displayed. This displayed hostname is a sure sign that the active configuration has changed. Welcome to the Interface Types and Configuration module. By the end of this module, you should be able to describe interface types and basic interface configuration tasks. Interfaces are primarily used to connect a device to a network. However, some interfaces are used to provide a service or a specific function for the system on which it operates. On platforms running Junos OS, several types of interfaces exist. Management interfaces are used to connect the device running Junos OS to a management network. The actual designation for this interface is platform-specific. Examples include FXP0 and ME0. Internal interfaces are used to connect the control and forwarding planes. The actual designation for this interface is platform-specific. Examples include FXP1 and EM0. Network interfaces are used to provide media-specific network connectivity. Some media examples include Ethernet, SONET, Asynchronous Transfer Mode or ATM, T1, and DS3. Loopback interfaces are used to provide a constant and dependable hardware-independent interface. The loopback interface uses the LO0 designation on all platforms running Junos OS. Use the LO0 interface in conjunction with routing protocols to facilitate routing in a redundant environment that is independent of the individual physical links within that environment. You can configure a single logical unit for the LO0 interface for each routing instance. Each logical unit associated with a given routing instance can, however, have multiple configured IP addresses. Services interfaces are used to provide one or more user-configurable services, such as encryption, tunneling, and link services. Services interfaces can be provided through a physical services interface card or through software. Services interfaces provided through a PIC do not have ports or media associated with them, but have two-letter interface type designations as shown in this table. Junos OS uses a standard naming convention. Most interfaces have names based on the interface media type, the system slot number in which the line card is installed, the line card slot number in which the interface card is installed, and the port number for the interface card. The CLI almost always refers to line cards as flexible PIC concentrators or FPCs, and interface cards as PICs, even though the actual names of these physical components might vary between Junos devices. For platform-specific information, including details pertaining to the interface naming convention, please refer to the Juniper Tech Library website. You can access the website from the reference links document. In typical deployments, the slot and port numbering begin with 0 and increment based on the system hardware configuration. The example shows a sample interface name that illustrates the interface naming format. The highlighted interface name is for the fourth physical port, number 3 on a gigabit Ethernet interface card installed in the third slot, number 2 of a line card that resides on the first available line card slot, number 0 of a chassis. Other interface name designations exist that do not adhere to the naming convention. Interfaces with specific designations are created by Junos OS and are not directly associated with or dependent on physical interfaces. Some examples are LO0, Loopback Interface, AE, Aggregated Ethernet Interface, AS, Aggregated SONET Interface, and VLAN, VLAN Interface. Junos OS also creates a number of internal interfaces. These internally generated interfaces are non-configurable. Some examples are GRE, MTUN, IPIP, and TAP. Note that interface support varies between the different Junos devices. For support information, always refer to the technical documentation for your specific product. Each physical interface descriptor can contain one or more logical interface descriptors. These descriptors enable you to map one or more logical, sometimes called virtual interfaces, to a single physical device. Creating multiple logical interfaces is useful in environments where multiple virtual circuits or data link layer connections are associated with a single physical interface, such as in ATM and frame relay networks. Some encapsulations, such as the point-to-point protocol or PPP, and the Cisco High-Level Data Link Control or Cisco HDLC protocol, support only a single logical interface, and its logical unit number must be 0. Other encapsulations, such as frame relay, ATM, and tagged Ethernet, support multiple logical interfaces, so you can configure one or more logical unit numbers. The unit number and the circuit identifier are different in meaning. The circuit identifier identifies the logical tunnel or circuit, whereas the unit is used to identify a logical partition of the physical interface. Although not required, it is generally considered a best practice to keep the unit number and circuit identifier the same. This practice can greatly aid in troubleshooting when you have many logical circuits. Junos OS devices can have more than one address on a single logical interface. Issuing a second set command does not overwrite the previous address, but rather adds an additional address under the logical unit. The example displays the use of the CLI's rename command, which is an excellent way to correct addressing mistakes. Also, note that Junos OS forms interior gateway protocol or IGP adjacencies over all subnets when the IGP is configured on a logical interface. This behavior is worth noting because some vendors' products form an adjacency over the primary address of an interface only. Certain physical interface properties can be adjusted. You can change the data link layer protocol for a particular media type, for example, PPP to Cisco HDLC, and you can turn keep alives on or off. On Ethernet interfaces, you can hard code the duplex setting to either half duplex or full duplex. You can specify the link speed on certain interface types. You can vary the MTU size from 256 to 9,192 bytes. Clocking refers to the interface clock source, either internal or external. Scrambling refers to payload scrambling, which can be on or off. You can modify the frame check sequence or FCS to 32-bit mode. The default is 16-bit mode. You can also enable local or remote loopbacks or set up a bit error rate or BERT test. Some logical interface properties include protocol family, which refers to the protocol family you want to use, such as Family INET, INET 6, ISO, MPLS, or Bridge. Addresses, which refer to the address associated with the particular family. For example, IP address using Family INET. Virtual circuits, which refers to the virtual circuit identifier such as a data link connection identifier or DLCI, virtual path identifier or VPI, virtual channel identifier or VCI, or VLAN tag. Other configurable options include Inverse Address Resolution Protocol, or INARP, traps, and accounting profiles. All interfaces have the same configuration hierarchy organization. Junos OS considers all properties defined directly under the interface name to be the physical properties of that interface. The unit number represents a particular logical interface or subinterface. Junos OS considers all properties defined directly under the unit number to be the logical properties of the corresponding subinterface. This is a basic configuration example that includes multiple interfaces, multiple protocol families configured under a single logical unit, and multiple IP addresses configured for a single protocol family. While a single logical unit does support multiple protocol families, such as INET and INET 6, you cannot configure a second protocol family in conjunction with the Ethernet switching protocol family. This example illustrates this point. The example also highlights the use of the preferred and primary configuration options. The preferred option is used when you have multiple IP addresses belonging to the same subnet on the same interface. This option enables you to select which address is used as the source address for packets sent by the local system to host on the directly connected subnet. By default, the numerically lowest local address is chosen. In the example, the default behavior has been overridden with the preferred option, making 172.19.102.2/24 the preferred address. The primary address on an interface is the address that is used by default as the local address for broadcast and multicast packets sourced locally and sent out the interface. The primary address flag also can be useful for selecting the local address used for packets sent out unnumbered interfaces when multiple non-127 addresses are configured on the loopback interface. LO0. By default, The primary address on an interface is selected as the numerically lowest local address configured on the interface. In the example, 172.19.102.1/24 is the primary address for the GE0/0/2.0 interface, because it is the numerically lowest address configured on that interface. 192.168.200.1/32 is the primary address for the LO0.0 interface, because it is assigned the primary option. Interface support varies between Junos OS devices. Refer to the technical publications for detailed information for your specific product. To quickly verify the state of an interface, you can issue the Show Interfaces terse command. To filter the displayed output to an individual interface, add the name of the interface. Instead of a name, you could also use a wildcard. For example, GE star to match all gigabit Ethernet interfaces. In the sample output, you can find the admin and link status, the protocol family details, and the address information for the specified interface.